Hello, I am Mr. Fixit from ES Repair. In this video, we will discuss the role that hubs, switches, routers, and modems play in your home network. The hub is known as an Ethernet hub, an active hub, a network hub, a repeater hub, or a multi-port repeater. It's located at the edge of a network. Devices connected to the hub creates a private local area network, or LAN for short. This allows multiple devices to share a single internet connection and transfer data between the devices. Hubs are not that sophisticated. They do not track the MAC or IP address of connected devices. It simply rebroadcasts an incoming data packet to all the devices at the same time. If a connected device doesn't need the packet, it is dropped and ignored. Hubs have no memory. If a data collision occurs between multiple devices, the data is lost because the devices tried to send data at the same time. The hub must reset the connection, and then the sender must resend the data packet. The hub divides the incoming bandwidth by the number of connected devices. For example, let's say the maximum bandwidth is 100 megabits per second. With only one PC connected to the hub, it will receive the full bandwidth. However, let's say there are 4 PCs connected to the hub. Each PC would get 1/4 of the bandwidth, which is 25 megabits per second per PC. Hubs operate in half duplex mode. They can only receive or resend data at a time. Hub networks often ran slow because there was little control with the flow of data. A hub was not a good choice to use with several devices, but were cheaper than buying a network switch at the time. Hubs started phasing out in 2011. A network switch is the advanced version of the hub. Unlike the hub, the switch keeps track of the MAC address of each device connected to each of its ports. When a data packet is received, it reads the packet's header, checks its table of connected MAC addresses, and sends the packet to the assigned port. MAC address is short for Media Access Control Address. It's a unique identifier assigned to a Network Interface Controller, or NIC for short. Any device connecting to a network must have a unique MAC address assigned to it, and it cannot be changed. The switch also allows each connected device to use the full bandwidth. So even if the bandwidth is 100 megabits per second, each connected device also gets 100 megabits per second. Since each port has a dedicated line, and a device connected to the switch port can transfer data to any of the other ports at any time, and the transmissions will not interfere, thus preventing data collisions. The network switch has one transfer and one receive line per port, allowing it to operate in full duplex mode, where devices can send and receive data at the same time. Next up the network chain is the router. This is an important device that plays a major role in networks. If you ever used a TomTom or a Garmin when you travel, they will show the quickest route to reach your destination. A router performs the same function on the network. It finds the quickest route for the data packet to reach its destination, hence the name router. They are connected to 2 or more networks, usually a Wi-Fi network or LAN, the Internet Service Provider, and beyond. When a data packet is received, it refers to its routing table or map to see the quickest route to send the data packet. The router updates its routing table periodically as changes on the network occurs. The main purpose of a router is to connect multiple networks and forward packets destined either for its own network or other networks. The router doesn't read the data packet itself. It reads the header information on the data packet to determine its destination. Today's router has multiple functions. Not only does it route the shortest path for data packets, it can also function as a switch. It also provides security to protect the local network and the connected devices by using network address translation and a firewall. The router uses NAT to hide a device's IP address from the outside world by modifying the IP address on the data packet as it is sent to the internet. When the data packet has returned, the IP address is converted back to the original address and sent to the device on the LAN. Computers outside the network will only see an altered IP address, making it difficult to hack a specific device on the LAN. The firewall monitors incoming data traffic and verifies the purpose of the incoming data. Anonymous connection attempts, identification protocols which use port 113, and so forth are all blocked by default. The firewall is also built into the NAT. If an incoming data packet doesn't match the NAT's mapping table, it will automatically drop the connection. It will only permit connections that were initiated from within the LAN. When a connection is made, a port identification is requested. There are thousands of ports that can be used for a connection, but only a handful that are commonly used. For example, port 80 is used by web browsers to surf the web. Port 25 and port 110 are used by mail servers to send and receive emails, and so forth. Uncommon ports are usually blocked by either the router or the device's firewall software. A typical connection will have the IP address of the device followed by a colon and the port number requested for communications. Remember that routers only have a basic firewall. The NAT and the firewall can inadvertently block anticipated incoming connections. In this case, the router provides port forwarding to allow remote computers on the internet to connect to a specific computer or service within a private LAN. It's often used to ensure the router sends the incoming connection to the specified device in the port forwarding list. For instance, if you are hosting your own web server and you want to be sure that web surfers can find your website, you can use port forwarding to tell the router when the specified port connection arrives to send it to your web server's IP address. Online games will often use port forwarding to improve the gaming experience. Some routers also have MAC address filtering, which can help increase security on your network. This feature helps by comparing a device's MAC address to the MAC filter list. If the address is on the allowed list, then that device connection is accepted on the LAN. However, if the MAC address is not on the list or is on the blocked list, then the router blocks the connection attempts, even if the device has the correct password. To simplify the configuration of a network, the router uses the Dynamic Host Configuration Protocol. The DHCP server enables computers to request IP addresses and networking parameters automatically, reducing the need for a network administrator or a user to manually assign IP addresses to all network devices. When a device connects to the network, a handshake occurs to establish communications. Once connected, the DHCP provides configuration, assigning an IP address and information to access the network and internet. The device will then accept the new configuration and perform a test. The IP address is usually assigned on a 24-hour lease period, at which time the device can choose to renew the IP address, or the DHCP can assign the IP address to another device. A gateway is a node on the network that connects to other networks or the internet, often called the default gateway. Any data packet not intended for the LAN is sent to the default gateway to be processed and then sent to either another network or to the modem. The modem is the gateway between your private LAN and the internet, also known as a residential gateway. The modem connects to a wide area network of your internet service provider. The modem is usually a digital subscriber line, which uses telephone wires, or a cable modem. Other modem types are fiber optics and cellular wireless. Your modem sits at one end, while your ISP's modem sits at their other end, creating a bridge. The modem converts the format of your local network into the format used by the ISP via telephone, cable, fiber optic, or cellular. The ISP modem then reconverts the format to meet their wide area network and vice versa. Many modems today provide a gateway to the internet, functions as a router, and functions as a switch. Modems are often referred to as broadband modems because they provide an always-on internet access, cable TV, and telephone services. Some modems only have one Ethernet connection, or has no Wi-Fi capabilities, which would make adding a router very handy if you need Wi-Fi or need multiple Ethernet connections. Cellular companies have mobile hotspots to create a LAN by using their cellular service. It's much like your cell phone, but this provides internet services through a wireless broadband modem. It can be a standalone modem, or it could be a USB modem that connects to the PC to provide internet service. It's commonly used when no other internet service is available in the area. Most cell phones today can also create a mobile hotspot called Tethering. You set up the hotspot on the phone and any Wi-Fi device can connect to the phone to access the internet. This feature is often used while you're traveling. Well, in this video I've shown you how a hub, a switch, a router, and a modem all play a role on your home network. Well, I'm your host, Mr. Fixit from ES Repair. Thank you for watching.